So this one is 6-29, and what we're trying to do for this is find C so that VC of T is critically dampened. Critically dampened. Okay, for T is greater than or equal to 0, and then plot, and plot. All right, so let's start this one. We have an equation here. Let's look at always our first bit. Draw. I'm going to do these steps. 1. Draw t equals 0 to this. 2. Draw t equals 0. 3. Draw t equals infinity. These all give us initial value properties, and then we can go from there to be able to solve this, to be able to get our critically dampened equation. So let's look. T equals 0 from the minus. So what do we happen when we get up to, when we go from negative infinity to 0, this is going to be a line and this is going to be open. So let's redraw that. We've got 18 resistor. This is still switched because this is going to open at t equals 0. So that's totally through. That's our switch. This is our point, our resistor, a line because that's our inductor there, positive, minus. Okay. And this one is our resistor, and this is an open, come down around here to VC. And what are our values? 6, 6, and 6. Okay. So, voltage source, resistor comes through, voltage source, resistor hanging. So that makes this one a little easier to do. So, what is our voltage source? Well, this whole bit is an empty pipe. So whatever this is, whatever voltage it is at this point is going to be down here too. So in order to solve this, we're going to need to find our current through our inductor. And so what do we have here? We have one loop. So we could solve this V equals IR, however we want to solve this going through. But, what is our, we have 12 here. So these are facing the opposite direction. So it's going to be 12 minus 6 for our thing. So that's going to be 18 minus 12 equals 6. So VC of minus is going to equal V equals IR. So our voltage is going to be 6 and times our current I. And then it's going to be plus whatever this is, and that is going to be 12 plus 12. So again, I'm going to solve through 6 times I, so whatever our current is coming out here, V equals IR, right here, and then plus 12, because this is just the loop from here to here. And then our IL is from 0 to this side is going to equal, well, we've got our two differences, so this is going to be 18 minus 12 for our two power supplies, and then this is going to be the two resistors in between, V equals IR, V equals IR, V over R, and so this is going to be 6 plus 6, and that's going to be equal to 0.5. So that is our current coming out of our inductor. So our current, our total current coming through here is 0.5 amps. And then, of course, our current coming through here, because it can't go through anywhere over here, has to come down through this piece. So this is our current that we've solved back up in here, going through this one minus the 12 to get to ground. And so this I is going to be equal to 6 times 0.5, because we just plug this into I, plus 12, and that's going to equal 15 volts. Okay, good. And this one is 0.5. Okay, that's good. All right, I'm happy with that. And now t equals 0. Well, at t equals 0, this is just, the only difference is this is going to pop up and open. So at t equals 0, our voltage of the capacitor at 0 is going to equal our voltage of the capacitor, because this is all of a sudden, this is going to be open, so this is going to be changing. And so what is this changing? Well, previously we had 15 volts at this point, right? Because it's 18 minus IR. This was 6 times 0.5, so 18 minus 3 equals 15. So this is 15 volts all the way up here, empty pipe. So this is going to be 15 volts. That's what it's going to start out as at 0. And then what else do we've got? IC at 0, our current going through our capacitor at 0 is, now let's look, our current going through the capacitor is going to be equal to, well, if this is open, we know that this was, what was it? A half an amp coming through here, because again, it couldn't have gone anywhere over here, so it was a half an amp the whole way through here. So if we close this, we know this has to be a half an amp coming out. So this is going to be a half an amp in the opposite direction. So this is going to be minus 5 amps. That's the current coming out of that capacitor. And what do we got? Our good. This is also our IL. IL at 0 has to be what? Again, well, if we're going in, which direction do we pick? It's going to be, well, let's go in the same direction. Let's go up this time. So that's going to be IL is going to be equal to 5 amps. Because it's going to come out from that source through. All right. And now, what else do we have? Our voltage over this. So our voltage across the capacitor, VC of 0. Prime, so this is as we're changing or whatnot, we're going to have equals to IC of 0 divided by our capacitance equals minus 0.5 divided by C. Okay, that's pretty not too bad either. So now let's do at T equals greater than or equal to 0. So that's going to look like this. We get a positive and negative. Okay, because once this is switched, we get rid of this entire side over here. So once we get rid of the side, all we're left with is this. So this has got our voltage source, a resistor, and a capacitor. We also have an inductor in there, my bad. That goes back through. So this is 12, this is 0.1, this is 6 ohms, this is 6 ohms, this is VC. And our IC is going that direction. Okay, and IC is going that, so IC is going right. Good, all right, we're set. And so again, to go through this bit, we're gonna need more paper. We now use our alpha to be able to look at our critically dampened. And so for this, our alpha constant, if we look in the book, equals R over 2L for a series RCL circuit. So this 6 and this 6 are just going to get added up to 12. And then we're going to have 0.1, 12, and whatever this capacitor value is, which we don't quite know yet. And so our resistors are going to be 6 plus 6. And then our inductor is going to be 2 times, what's our value? 0.1. 0.1, that's going to equal 60. Okay. And then for a dampened response, alpha omega 0 must equal alpha for critically dampened, for crit damp. And if that's the case, then 1 over the square root of LC has to equal 60, because that equals that equals that. Therefore, we know our value of L here. So our L we can plug into 0.1 and square both sides, multiply by LC, and that's going to give us our C equals 1 over 360 farads, so under 1 farad. And now we're going to grab the next paper for this and kind of just keep working down. So, therefore, we're going to be able to plug back into our V prime that we picked out over here. This is our C value. VC prime of 0 is going to equal to negative 0.5 divided by, what is that, 1 over 360. And if we solve that out, that's going to equal minus 180 V per second. And so also, if we look back at our circuit, if we look at up here, over infinity, this is just going to become an open circuit, which means this is going to be filled with the same voltage that's over here. So at V of the capacitor at infinity, it's going to equal 12 volts, because again, 12 volts, 12 volts. And then to get the total critically dampened, we can use the equation Vc of t equals Vc of infinity plus B1 plus B2 t. And then this is going to be E up minus alpha t. And we can start to substitute in some of the values. So we have Vc of infinity, that's going to be 12. B1 and B2 we don't have at all, so plus B1 plus B2t we don't have. That's going to be there. Our E up, our minus alpha, we do have alpha, which is 60. Minus 60, and t is just going to stay in the problem. So now we need B1 and B2. So we have to find B1 and B2 with the initial conditions that we got way up here into all of these different slots. So our initial conditions for this one, actually let's just do Vc of t equals that. Our initial conditions, B1 equals Vc of 0 minus Vc of infinity is going to equal our initial, which is 15, minus our infinity, which is 12, equals 3 volts. That's our B1. That one was easy. And then our B2 is going to equal our Vc prime of 0 plus alpha Vc of 0 minus Vc that. Boom. Boom. And then we're going to get, and that's going to equal to our Vc 0. So we already solved this one up here. Vc prime of 0 equals minus 180. 180. And then plus our alpha, which we got before, is going to be 60. 60. And then we have our same voltage 0 and voltage capacitor 0, voltage capacitor infinity. So it's same as here. 15 minus 12. And this is going to work out to be blah, 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 160, 12. So 3 times 60 equals 180. So this is going to equal this. So B1 is going to equal 0, equals B2. That's nice and easy. And then finally, our Vc of t, our voltage across the capacitor through time, equals 12 plus 3e to the minus 60t. And we got that by saying 3 plugs into here, 12 plus 3e to the minus t plus 0. So, boom, solved.